What's up, fungal associates? Welcome to Completely Arbortrary. This is the podcast about trees and other related topics. I'm one of your hosts. My name is Alex Crowson. And then over there, and also...
And then, otherwise,
sorry.
Side note.
Casey Clapp.
Hi.
Now, Casey, before we get into this week's tree, your book, The Trees Around You...
Yep.
is officially 1 week old.
It's out there. It is. This is officially the 7th day.
Yes.
On this day, Alex, my book rested.
It's just you just made so many sales in the last 7 days.
Exactly. It's just insane. Alex, you're totally right. Thanks for bringing that up.
Congratulations.
I'm pretty stoked. Thank you.
Yeah.
As of right now, our event last week was amazing.
Yes.
So,
I cannot believe how it ended.
No, that was insane. And then, gosh, you and I, we actually just nailed down another event that we're doing up on Orcas Island. Ever heard of it?
That's right. It's not orcas.
It's going to be so cool. We're going to go there. Alex is going to play some music. We're going to talk a little bit about the book. We're going to do a little trivia.
Yeah.
So
you can even say trivia.
Exactly. You could say that if you wanted. So that's going to be on the 19th and 20th of October.
Yep.
That's going to be a Sunday and a Monday. So take off Monday and Tuesday.
Yeah.
Don't work on Sunday if you had planned to, and then come out and visit us over there in the tropical San Juans.
Make a trip of it.
Yeah, it's a whole thing.
If you come to this event and tell us, I made a trip of it, that's the key. That's the code word.
That's the code word.
We will give you something for free.
It will be it'll be pretty cool. I mean, we already have it planned.
Yes, of course. Well, Casey, speaking of plans, we have plans to talk about a tree today.
We do. We have plans to talk about a tree.
And out of the sludge, down in the bayou, out of the sludge comes a swamp monster.
That's right. We call it the swamp Tupelo around here.
Swamp Tupelo. This is Nyssa biflora.
This is exactly that.
And we have to talk about this swamp monster after a quick break. We'll be right back with Completely Arbortrary. Welcome back to Completely Arbortrary. Today we're talking Swamp Tupelo. Nyssa biflora.
Why did you say it with like a strange Italian accent?
He's got a very nice biflora.
Ah, okay.
Wow, I couldn't even... Let me try that one more time.
Yeah, I thought that was really beautiful, but go for it.
He's got a very nice biflora.
Yeah, that is really nice.
Yeah.
Yeah, well, and do you know what that means?
Two flowers.
Yes. Well done.
The Nyssa, I guess, is Tupelo.
Well, not actually.
What is Nyssa?
Well, Nyssa refers to a nymph, like a water nymph.
No kidding?
Yeah.
Oh my God.
Because these are found, generally speaking, the Tupelos in very wet habitats. Generally speaking, I should say.
This isn't a swamp monster at all. It's a swamp nymph. Well, maybe on a twist on the old mythology.
Yeah, there you go. I mean, well, what nymphs always were like the things in water that I guess there's also sirens, and the sirens would call ships in and crash on the sea.
Nymphs are different. Yeah.
Yes, nymphs are in fresh water.
Yes.
And they're like these like sexy little creatures that are very much like, yeah, I'm jumping in that water because look at that thing.
Playful, nude, sort of mischievous.
Yes, yeah.
Little guys. Casey, let's imagine, as we do every episode, that you and I are walking through the bayou. Maybe the Everglades. I don't know. Somewhere down there.
Okay, yeah.
Where it's wet and warm. And we come across some water tupelos. Casey, let's ID this tree.
Let's do it. All right, so here is the thing. This is a tree that you can pretty well easily figure out that it's this tree because you will find it in swamps.
Yeah.
Specifically, you will find it in blackwater swamps. You will also find it in like headwaters where like this is where a seepage kind of comes out and then becomes a river or something like that. And you'll also find it in and around ponds.
Now, when you say in swamps,
yes,
you're talking in swamps.
That's exactly what I'm talking about.
Not on the bank of a swamp.
Nope.
Okay.
Nope. There are some trees that will do that. This tree will do that. But you will find it often growing inundated with water well up above the base of the roots.
Wild.
I've seen this in several different swamps, particularly the Congaree National Park swamp, which is, I think, just the Congaree Swamp National Park.
Down there in Florida?
That was actually in South Carolina.
Oh.
But you brought up the Everglades. The Everglades, you'll definitely find some tupelos down there. But generally speaking, you'll find this one growing mostly kind of up a little bit higher. It grows down into Florida, and it grows way over, but there's another sub-variety that grows down, like the Apalachicola area. That's in kind of the Florida, Georgia area.
Okay.
But with our particular tree, it will be growing. Well, another place I saw it is actually in Georgia. It was the Okefenokee National Wildlife Reserve.
Great name.
It's the best name. I truly love that place. I would go back any day.
You know, Apalachicola is what we call whiskey where I'm from.
Well, where are you from?
Wouldn't mind a cola. Oh, yeah, me neither.
Yeah, wouldn't either. If I could play not a ukulele, a banjo right now, that would feel great.
I wish I had one.
Well, so this also goes very well with the name Tupelo, which actually comes from Creek, meaning swamp tree.
Oh, wow. Okay.
Yeah. So everything about this tree, from swamp Tupelo, that's really means swamp tree.
It's a very strong theme.
It really,
I really like
is.
when trees are like this.
Yeah, it's like everything about it just matches its personality perfectly.
That's great.
Yeah. So let's say you're in there, because there's also another very closely related species, which is called Nyssa aquatica, which is the water Tupelo. Now, let's act like we are not as confused as everybody else out there, but we are. There is the water Tupelo, Nyssa aquatica.
Okay.
Okay. Then there's the swamp Tupelo, Nyssa biflora.
Okay.
Then there's also the black Tupelo, which is Nyssa selvatica.
Okay.
So these are all kind of helpful to one extent, because you have the water Tupelo. That one is aquatica. So great. Aquatica, water, makes sense. Then you have selvatica, which means of the forest.
Yeah.
So you have, this is more of an upland species that grows in forest conditions.
Forest tree?
Yes, you have the forest Tupelo, you have the water Tupelo, then you have the swamp Tupelo, which I really wish there was a scientific name that was like swamp, but instead they mean biflora, which of course means like two flowers.
Sure.
But
this is 3 of the 5 colors in Magic the Gathering.
Yeah, why can't we get that? My God.
Get a mountain Tupelo and a plains Tupelo.
Then I think we'd be somewhere.
Wow,
yeah.
that'd be fun.
Yeah, well, maybe we can think of some. So you don't want to get confused between the water Tupelo and the swamp Tupelo.
Sure.
So the big way to tell is the size of the leaves. Our leaves for our swamp Tupelo, they're alternately arranged. They are simple. They are elliptic, which means they kind of look like an elongated oval, or ever so slightly obovate, meaning the tip or the widest part is closer to the tip of the leaf. They're about 3 inches long to 6 inches long, only 1 to 2 inches wide. So they're really kind of a long, skinny leaf is the best way to imagine them.
Interesting.
Now, in comparison, our water Tupelo has 4 to 8 inch long leaves. They are much larger and they are much wider.
Okay.
So remember that as you're going through looking at these trees.
Now, do water Tupelo and swamp Tupelo grow in the same vicinity?
They do. They really do. And that kind of is what makes them hard to distinguish, because they both grow in similar ways in similar places, but the kind of particular spaces are a little bit different. So our swamp Tupelo will grow in those blackwater swamps, which looks like tea, essentially, where you kind of, if you dip your hand in, it will quickly disappear because there's just this black, it's just like black nutrients dissolved in the water.
That literally gave me chills.
It's because this is a swamp monster, Alex.
That's very freaky to me. I'm very scared of dark water.
Oh, absolutely. And also, like, it's pretty scary because there are literally crocodiles and alligators in there and snakes. Like, it is truly the scary tropical kind of esque zone that you would be couldn't. There's also like snapping turtles, which is like horrifying.
Those are awful.
They are awful, and they are really fast at attacking.
Yes.
I've seen a video and I was like, that guy's an idiot. Oh my God.
And they move fast too. Their little bodies.
Oh, in the water, certainly. Yeah, they'll just whoosh around. That sounds more like freaky.
Scooby-Doo when he's trying to run away.
Yeah. Oh, man. Yeah. So that is, you'll often find it, like I said, seepage and bogs, whereas aquatica is usually found on mineral soil. So it'll be in an area that is inundated with water, but it's going to be where you can see, there's like actual soil there.
Oh, okay.
Versus swamp Tupelo, it will be inundated with water. You won't even see the soil that it's growing in. And the soil that it finally does grow in is so filled with organic matter that it's literally like a swamp. You know, we're going to find fossils of this particular species forever in the next several million years.
Yeah.
Because all of its leaves and parts are falling straight into water, zero oxygen, and then they just sit there and become fossils.
I understand that swamp water is an anaerobic condition.
It very much is. Good job, Alex.
Oh my God.
But let's not get ahead of ourselves here, sir. We have lots more to talk about before we talk about those anaerobic conditions.
Wow, Casey. Can we maybe pivot to bark?
We sure can pivot to bark.
Because I'll tell you why I'm interested.
Yeah.
Because I think this tree lives in water, and my first thought is, that gonna rot.
It is, exactly. I also have that same thought. I don't know how. I don't know why. It's just... it's fine with it.
It clearly is okay down there.
And it doesn't have bark that's like outrageously special or really well designed for something.
Okay.
Like, you know, if you see fire adapted trees, they have a certain kind of bark.
Sure.
It's usually
thick
thicker,
and craggy.
Exactly. Something like that, or like flaky or papery, something that's very obviously different than what you see for a like super fire dependent kind of species.
Okay.
So I would expect that you would see some like swamp variety of this, you know, like you have your standard variety, then you have your swamp variety.
Sure.
But you don't
Something
see
unique
it.
Looking.
Yeah.
It just looks like tree bark.
It does. That's
unfortunately.
It. Now the Tupelos, all of them create themselves some nice, like really intense furrows and like these, I don't know, they're kind of like irregularly cracked, and each crack becomes like a squarish, rectangle-ish kind of little part. So they're broken up both vertically and horizontally into these tiny little kind of raised plate ridges thing. It's kind of hard to describe. You kind of have to see it.
I'm kind of imagining like the surface of a dried lake.
Yes, if it all dries in like little tiny squarish rectangles.
Yeah.
I feel
like I've seen that.
You definitely have it. I'm sure you've seen this kind of bark. I mean, I think I've taken some pictures of this kind of bark. In fact, of this particular tree, not this, not an individual, but like of the species.
Sure.
But generally speaking, it will also be kind of smooth at the all up and down. So it's just kind of a light gray, smoothish, and then as it gets older, it develops these more thick ridges and cracks and things. But it's just kind of like it's for all intents and purposes normal looking bark.
It's swamp utility bark.
It's swamp utility bark.
But it's not even really swamp utility.
This is all bark. I mean, but I guess swamp utility is pretty much the same as any other kind of utility.
I guess it depends on what is keeping this tree from getting waterlogged and drowning.
Yes. Now that is our topic for a little bit later.
Well, we'll put that off.
Yes, we'll put that off. But it does have to do with the bark to a certain extent. But it's not like something physiological with some change in the bark.
Sure.
So it's really it's kind of just normal bark. It just happens to be waterproof at the same time.
That is interesting.
Extra waterproof, maybe?
Yeah, maybe.
I don't know.
Well, Casey, maybe scientists should study this bark for scuba gear.
I think they probably should.
The best design comes from nature.
It does, baby. That's what I'm talking about.
Well, Casey, I'm really interested to find out what the fruit and flower are like of this tree because I have no idea what to expect.
It's not really something exciting.
Well, that's too bad.
Except for the fruit. I'm sorry. That was too much of a whole statement. And let's go back. Ask me again.
Talk about the fruit.
Oh, Alex, I would love to, but let me first start by telling you the flowers. Who cares?
Really?
Yeah, they're little tiny guys. They don't really do a whole lot. Usually it's dioecious, so you have two different kind of plants. But the thing is, they're just like kind of tiny.
This is the sound effect of this kind of flower.
Yes, it's like, there you go. Do your job. Get out of here.
Yeah.
Now, I just said dioecious. I take that back. They are not dioecious. They just have two different kinds of flowers.
Interesting. What is the distinction?
Well, the male flowers, of course, between being dioecious and not dioecious, monoecious, one is you have two different flowers on the same tree, male, female, pollen producing, seed producing, versus having two different trees do that. So that's dioecious.
Right. But what did you mean by this tree has two different kinds of flowers?
Oh, that means it has male flowers and female flowers.
Oh, so it's monoecious.
It's monoecious, I believe. Yeah.
Oh, okay. I thought you were saying it was some third thing.
Oh, no. Yeah. Well, the third thing would be perfect flowers?
Oh, sure. Yeah. How about that?
There you go. So
all
there
right.
you go.
Full circle. Yeah, the flowers suck.
Come around.
But they produce a fruit. What is the fruit like?
The fruit, I love. The fruit are like these little blueberries, and they are so adorable.
They're cute.
They really are cute. They look like I don't know, cobalt blue little drupes that come out, and they are drupes. They have a little hard seed inside, and they have little blue bits around them. The scientific name, Alex, we should note again, is biflora, right? So this is Nyssa biflora. That is because initially they said, oh, well, this is a variety of the black Tupelo, which is Nyssa sylvatica, that just happens to grow in swampy areas, but this one tends to always have 2 flowers, which isn't precisely true. Usually they have 1 to 3 flowers.
Okay.
But demonstrably, if you average it out, it kind of comes out to be 2 flowers each.
Okay.
So that one, it's a little bit squishy, but it's good enough at this point.
Sure.
So essentially, that means you have 2 little flowers that then turn into 2 little droopy berries that come out.
Beautiful.
Yeah, they're really nice.
Little, let's just say it, little testes.
They're little testes. They do look like little testes. And honestly, they are, I don't know, that's...
Delicious little testes.
Delicious little testes.
They're oblong too.
Yes, they are. They're oblong, and but they're like just the most beautiful. They're so beautiful blue. Which now that you're saying they look like testes, it's like, well, these are little blue balls that are hanging off this tree.
Oh.
It really needs to get some.
Poor tree.
Poor tree.
I see this one man made ice cream with these berries.
What?
Yeah.
Where did you see this? Okay, hold on. We're on a different series now, Alex. We can't just go jumping back into
That's
other
true.
things.
Oh my God, this isn't just desserts.
But what is it? Tell me more.
Well, he made black Tupelo fruit ice cream.
Wow.
Excuse me, it's not ice cream.
What is it?
He made black Tupelo fruit honey sweetened whipped butter. It's fruit butter.
What?
Which sounds, my mouth is watering looking at these photos.
I have never heard of anything like that before.
There you go.
That's incredible.
You can do all sorts of things with whipped butter.
I wonder what it tastes like. I don't even know what these berries taste like.
Yeah, I'm interested.
I can't even imagine. Huh. All right. Well, anyway, they're adorable.
Yeah,
I like them.
They're great.
They also, generally speaking, these trees, if they go through their fall colors, they do go through their fall colors while their berries are there. Their fall color is usually a bright red. So you have this dark blue berry hanging all around these like very bright, like absolutely vibrant red leaves.
That sounds pretty.
They are stunning.
Have you been there in the fall and seen these?
I have not, but I have seen their close relative, the black Tupelo, which we have all around here in Portland, and that color is off the charts.
Oh, exciting.
Yeah, really lovely.
It's about that time.
It really is. It's coming up real fast.
Wow. Get
Now-
out your sweaters and your pumpkins.
I have 2 sweaters today and a raincoat. It's
yeah.
such a delight.
It's nice and chilly.
In fact, I'm wearing some Cozy Earth stuff right now. So
Are you really?
Hit us up, you guys.
Shit.
Yeah, it's a nice little sweater.
I slept in my Cozy Earth last night.
Yeah, there you go. It's sheets I use. Anyway, guys, go email them and say, I will only buy your stuff if you sponsor this podcast. And then don't or do buy their stuff. I guess it really doesn't matter at that point.
Yeah, we need them back. Well, Casey, that's the tree.
That is the tree. There is one final part that I actually wanted to talk about, which we don't generally talk about because it's not really an important aspect most of the time. But the trunk itself is really swollen at the base.
Yeah.
I don't really know why, other than motion of the tree.
Really?
But it really just becomes very widely buttressed at what is approximately the average water line.
Sure.
So you'll never see it just be like really, really swollen underneath the water or above the water significantly. It's always generally wherever the water line kind of is averaging out. That's usually where the kind of the middle average section of this swollen part is.
Now, as a human being, when you get, let's say you fracture your tibia.
Yeah.
If you go get a scan of your bone, you may not even know that it's fractured, but you'll see a little bump on either side of the bone. The bone swells.
Yes. Yeah.
And so I'm wondering if this thing's sitting in the water's pushing up against it. It's constantly like when your friend is a little bit of a crazy driver and you have to hold onto that little bar up here.
Yeah.
If it's like constantly like flexing its core to not be knocked over.
Yes, that right side where you're holding on is going to get bigger and stronger.
So I'm wondering if this is sort of like little fractures over much time create this sort of like swelling in the base.
Speaking as a tree, you are so perfectly spot on.
Really?
Yes, because that is a very common thing that trees do, where they will put on more wood. So as they move around, right,
I knew that.
they add more wood.
Yep.
So there has been moments, or individual specimens that I've looked at where a branch grows out. And then there is another thing that it kind of hits. Maybe it's another branch growing in the opposite direction or in the perpendicular direction. So one branch grows out and it lays on top of a second branch or a telephone pole or something, telephone wire. Then it gets heavier and starts to rest on that other branch. That becomes a point where the tree starts to have inflection. So it only moves and bends and sways beyond where it's laying on that branch.
So it's like a new joint.
It's a new joint, and then you look at the size of the branch in the between on the other side of this little connection point, and it's really thin.
Okay.
But then where it grows out beyond its resting point, it gets really thick.
Interesting.
Because that's the part that is moving, and everything else is just supported. It basically just becomes a conduit. You just put little teeny tiny rings, but it's not moving anymore because it's resting on that other branch.
Wild.
Yeah, so you're exactly right.
Cool.
Trees will do that. In fact, in the instance where you have decay in the center bottom of a tree, they create exactly the same idea. We call it bottle butt. Have you any idea why?
It looks like the butt of a bottle.
It does.
Or you drink
done.
shit.
Or it's just not good. This is the...
I'm sorry I said drink shit. That's so disgusting.
What?
Because it implies that the shit has to be liquid, which is diarrhea. So I'm saying drinking diarrhea. And I just don't want to...
I'm glad that you got stuck on that.
just don't want to bring that energy today.
No, everyone, put that out of your mind. We're not going to let Alex, we're not going to let you edit this out so everyone can share this journey with us.
Everybody poops.
Everybody does poop.
Everybody poops.
Okay, so you're totally right. But imagine an old Pepsi bottle or Coke bottle where the base of it is like, I don't know, 1.5 inches or 2 inches wide. Then it goes up more or less perpendicularly. Then it reaches a point above the label. Then it goes whoop down to a skinny, tall neck.
Yep.
That is what trees do often if they have decay in the base of the tree.
Interesting.
And that is because if the decay starts to get large enough to where it weakens the base of the tree is where all the forces up above come down and kind of zero out because now it's going into the ground. So the base of a tree is a big inflection point when it moves. So as a tree is moving with this decay, it tends to move a little bit more because it's a little weakened.
Sure.
Because it's weakened and moving more, the tree reacts by saying, oh, I need to put on more wood. So it starts to develop a lot more wood around this decayed area and becomes wider faster than the non-decayed upper portions of the tree, which could be like, from the ground to 6 or 8 feet. And then above that, you have this really quick transition where it just goes right down into a normal sized trunk. So
interesting.
I think, Alex, all this to say, you're pretty right. I think you could be right because
that's the best I could ask for.
It's like, great, wonderful. Chalk that up for a win.
Pretty right.
Well, so I don't know for sure because I know that also there's a certain kind of bark in this new kind of growth that this tree will do, specifically in the roots. But it might be that also because there is an inundation of water all the time, low down, the tree's actually moving quite a bit.
Yeah.
So you end up getting this more larger buttressed base that responds to the looseness of the soil underneath because it's essentially just the muck at the bottom of a swamp.
Can I ask a couple brief questions about the decay thing?
Yes, you will. Okay, question 1. Oh, did I make you panic?
I'm panicking. Is decay negative space?
In terms of like pressure?
Does it cause like a hollow?
Yes, it does. Yeah.
It's eating away at
all the center,
matter.
the center wood. Yes.
Okay.
Yeah.
That's why it becomes weak.
Yes. Now, let's say instead of having a foot diameter thing, which is fully built and has all the structure in it, now you have a foot diameter thing that has lost 1/3 of its inner diameter. So now it's just not quite as strong in not moving or holding up everything else. It just moves a little bit more.
And that heartwood is the strongest wood in the tree.
Generally speaking, yeah.
Okay.
Yeah.
Now, my other comment, I guess, was that this whole process is not that unlike swelling in a human body.
Yes, yeah,
like
totally.
There's something wrong there, so your body sends resources to it.
Kind of the inflammation kind of thing.
Yeah, to protect it, right?
That's it, yeah, probably.
That's interesting.
So I think that there are a lot of parallels that we can see with this.
I don't know how swelling works, but that's my instinct is that you have an injury, so your body sends a bunch of blood to it.
Yeah, exactly.
And
to
it
help
swells up.
Exactly. And also I think it's a bit of a it helps protect it, but it also adds as much like fixing material as it possibly can.
Nutrients and shit.
Yeah, exactly.
And like new blood cells. Yeah.
Keep going, Alex.
I could probably be a doctor.
Listen, you are my doctor from now on.
All right, Case. Well, that's interesting. I like that swelling of the butt. Period.
Say nothing more. All right. Well, let us move on then to talk about something that I was very interested in. And this was actually initially sent to us by one of our listeners who said, hey, just in case you ever want to learn, there's some interesting things going on about swamp Tupelo. So I was like, okay, I got to learn a little bit about this tree.
You sent that email to the right person.
You sure did. You're like, hey, I really should take some instance. And of course, I love thinking about trees and things as like swamp creatures and like creatures of whatever.
Sure.
So of course I was like, well, I'm just going to hold off on doing this for a couple weeks until we can do it during our month where we all have to imagine it as a swamp creature.
Spooky times.
So the question is, Alex, how do swamp creatures live in the swamp?
Wow, that's a really good question.
Yes.
I think they have, I think the original swamp creature from the classic Hammer horror films.
Okay. Classic what?
Hammer. It's like the company who produced those movies.
Oh, okay.
Like the original Dracula and Frankenstein.
Okay, yeah,
and is it Swamp Thing? Creature from the Black Lagoon, whatever.
I think Creature from the Black Lagoon is the one that I'm kind of like always think of, but I could be wrong. I don't know.
Because I think one of those is like amphibian and it has gills.
Yes, exactly. It has gills, but it looks like a dragon-esque kind of like creature with webbed fingers and like 4 limbs and things. Yeah.
And then there's another one that looks like a ghillie suit, just like a bush.
Yes, yeah. And there's just like a person inside of it. You're like, okay. Clearly,
that's not a swamp thing.
That's not a swamp thing. That's just a person. These are the creatures that I want us to ponder.
Let's do it.
How do they live in the swamp? What are they eating? How are they breathing oxygen? Because we have to assume that they live underwater. We do have an answer for one. It has gills.
Yeah.
Wonderful. There's oxygen in the water. It breathes through it. Cool. Now, what if Alex?
Oh.
What if one of these swamp monsters isn't able to move around, come up out of the water, go down into the water, but is in fact stationary as a tree? Other term that people use often is sessile. They don't move.
A sessile?
Yes.
Okay, well that's not a stretch.
Nope, it's not.
It's really good.
Okay, so let me just okay, I'm gonna take this. I'm gonna drop this curtain here.
Drop the veil.
These are swamp things. These creatures, these trees, they live in swamps.
Yeah.
They don't live on the edges of swamps. They don't live kind of like, well, my feet are in the water. They are fully inundated for much of the growing season at the minimum.
It's very curious to me.
Exactly. So if anyone has ever gone to these 2 swamps we talked about, Congaree or Okefenokee, or any of these other swamps in the southeast area, this is probably one of the species that you've seen. And you can notice it really easily because it has that big buttress base that comes up. And it's growing in the whole water. So naturally, makes me think, how the heck does it do that?
Yeah.
Because most of the trees that you and I are ever familiar with, they will probably say, yes, we want some water, unless they're like a really hardcore desert kind of, warm adapted, low water kind of tree.
Sure.
They would love to have a little bit of water always available to them at their beck and call.
But this is too much of a good thing.
Too much of a good thing.
This is like the Tales of the Crypt.
Yeah. Huh?
Yeah. So here's my mental mental railroad crossings, right?
I have no idea where you're going with this.
I see trees and they're in soil, but as I know, a lot of that soil is actually air.
Yes.
It's oxygen and nitrogen.
There's a huge amount of it down there. Well, hopefully.
And that's the way that the tree gets like nutrients is through the roots, through porous roots, right?
Yes.
And water.
Yeah.
I mean, it has to soak it up somehow.
It does,
It's like a sponge.
It's like a sponge, and often there's some amount of fungus helping it out. But generally speaking, you're exactly right. You have roots that will absorb water and the nutrients that are dissolved in that water.
Yes.
Pulls it into the branch.
But now with the Tupelo here, you have conditions under there, especially if it's like black sludge.
Yeah.
That I look at that and I'm like, how can something like get nutrients out of that.
Yes. Now, that's the thing. The blackness of the water, that is indicative of there being a huge amount of nutrients.
Well, there you go.
Yeah, so this looks like what people sell. And often, honestly...
That's what my proctologist said, Casey.
This is something
the
that
blackness
people
of the water... It's actually proof that there are a lot of
There's a lot of nutrients in there. You know what? Honestly, I'm going to stick with it. I'm going to stick with it, Alex.
Wait, is proctologist your butt?
I think so. So the darkness, it's like compost tea is what I was going to note. Are you familiar with compost tea? Have you heard about this at all?
No.
Okay, this is going to be kind of a hot take, and I may get some people being like, you're an idiot, that's completely wrong. Other people will be like, thank God. It's this thing that some places sell.
Okay.
And it's essentially taking like a bunch of nutrient-rich detritus, like literal compost.
Yeah.
But instead of just keeping it right there in the ground and letting it go, they essentially put it into a giant tank. And then they fill that tank up with water and they kind of move it around or slosh it or let it sit, and it becomes the equivalent of these kinds of black water swamps.
Okay.
Where it's this really dark, like black tea looking liquid.
It's compost milk.
It is exactly that.
Okay.
Now, people will sell you this to say, oh, you want to add some nutrients and fungus and things to your soil, then we are going to add on all of this this compost tea.
Okay.
It doesn't really do a whole lot.
You just kind of like sprinkle it on your plants?
Yes, it's like you take a gallon or however much, and like people will sell you this, and they will come with trucks, and they'll just like literally water your entire garden with it.
Wow.
And the idea is that it's essentially some kind of fertilizer, some kind of means of grabbing nutrients from this one kind of stuff in a hyper concentrated fashion, and then delivering it and fungus and bacteria and things like that into the soil.
It sounds like a hipster scam.
It does. And it kind of is.
Okay.
Like, yes, you might get this little boost of nutrients, but those nutrients are already there in the soil. And if you just give it enough time, then all the other things will just like come around, and they live there. There's bacteria and fungi and things all over the place. Unless you have like something so completely denuded of all these nutrients, then you're not going to get it. And if you do have that, and you add this compost tea, it's going to get sucked up like that, and then it's going to be done.
Yeah.
Like, you need the actual conditions of the place to be supportive of a plant.
Sure.
Right?
So the tea is not like changing the ecology of the soil.
Yes.
It's just like it soaks up the nutrients from that one hit, and then it goes, where's the next one?
Give me more.
Suddenly you have a tree addicted to tea.
Exactly. And that, like, this is it. And so, like, people will sell it. Some people live and die by it. Some people say it's great. I'm like, nah, this is a little bit of a snake oil, but if you want to buy it, go for it.
Totally.
But all this to say, that kind of thing naturally exists in these black water swamps. That's why they call them black water, because the water literally looks like this black tea.
Sure.
So it's filled to the brim with nutrients, where things have fallen in and decayed in an anaerobic condition, or they just fallen and decayed normally, and then the water filled it back up. So they are filled to the brim with nutrients. But what they don't have is oxygen.
Sure.
That is the real limiting factor underwater.
Now there is there is oxygen in water.
Yes, but generally speaking, there are two things that kind of work against that. One, everything is trying to take oxygen from water. And so you have to have some means of putting oxygen back in the water.
I see.
And that usually comes from like riffles and hitting rocks and aeration from waterfalls and things like this.
Okay.
So if you
or other plant life, no?
They're not really producing any oxygen, because remember, oxygen comes from doing photosynthesis.
Yeah.
So that's going to be happening up in the green area.
And if it's the light, it has a hard time getting through the black tea.
Well, yeah, and so there's not going to be a whole lot of things growing underneath.
Sure.
That's exactly right.
I gotcha.
But on the other side of this, though, there is a lot of carbon dioxide getting put into this water because everything, including the roots, is still doing respiration. So respiration is the opposite of photosynthesis, where you take oxygen, add to a simple sugar, and then create a burning, which is a combustion equation. Then you get CO2 released and water.
Okay.
So in this case, you have a high concentration of CO2 in water that has a very low concentration of oxygen because it's a swamp. There's not a whole lot of like ruffles and riffles and waterfalls adding in new...
Ruffles and riffles?
Yeah, there's ruffles and riffles.
Say that one more time, Casey.
Okay.
Not ruffles and riffles, the first part.
Yeah, honestly, I think I made up ruffles. There are riffles.
I like him.
Thank you. Okay, let's stick to it. So you have microbes and things that are in the water. They are using any of the extra oxygen. Okay. There is very little light coming through, so you don't get a lot of new plants putting any oxygen in the water.
Sure.
There are no waterfalls because it's a kind of slow-moving or sometimes stopped pond or swamp. Yeah. So there's not really a lot of new oxygen getting put in by like aeration kind of things like waterfalls.
The way you would make whipped cream.
Exactly, precisely. Mm-hmm. But then you have the roots that are respiring, so they're using oxygen and they are putting carbon dioxide out. So you get a higher concentration of carbon dioxide and a lower concentration of oxygen.
Than normal, like river water.
Exactly. Okay. Or normal ground, where like you said, there's pores in the soil, so there's oxygen and air inside the soil.
I gotcha.
That is what trees are using to do all of their different respiration things.
Okay.
So that puts a tree growing in this situation, or really any plant, in kind of a weird predicament.
Because plants don't like carbon dioxide?
A lot of times, if there's too much carbon dioxide, it becomes a big stressor for them. Because it's just like if we have too much carbon dioxide and we need to breathe, and we're like, well, I'm actually not getting as much of the oxygen that I need, so the balance is kind of thrown off.
Interesting.
Yeah, especially down in an area where you are living in very anaerobic conditions inside that water, where there's almost no oxygen. How are you going to do? How are you going to live in that situation?
How does it live?
It's a great question, Alex. I'm glad you asked.
It's almost like I knew where we were going.
So, Alex, what these little guys do is they have created a series of adaptations which help to make them thrive in a situation where normally other trees would not be able to do it. So when they're in flooded conditions, they develop new roots that essentially accelerate the amount of anaerobic respiration that's happening. Okay. So anaerobic respiration is respiration in the absence of oxygen.
Seems like an oxymoron.
It is, right?
That oxy stands for oxygen, by the way.
That's an oxygen moron? Okay, come on. It really is. But this is something that can happen. In fact, it happens all over the place.
Okay.
So an anaerobic respiration, it's a similar thing as if you're moving really fast. So like you can't rebuild. Yeah, Alex just shakes his arms real fast. Exactly it.
Like this?
So it's like if you go on a quick sprint, you know, you're actually not breathing on a quick sprint. So anyone who like runs the, 100 meter, whatever, like the really fast, like we're just sprinting as quick as we can, the short distance, they are actually pretty much not breathing that entire time. And if they are, their body is not moving all of the oxygen from the blood into their muscles.
Really?
Yes. It's really kind of interesting where you will see them like get ready, take a deep breath, and then they will just book it as quick as they can.
Whoa.
Then afterwards, they will be breathing really heavily.
Wild.
Yes, but you are not breathing really heavily while you are sprinting.
Okay. That's anaerobic respiration.
Exactly. Now, if you are jogging, that is aerobic respiration, where as you're moving your body, you are taking these deep breaths. But that is the kind of more slow twitch muscle movement is the idea.
Sure.
Where you are slowly breathing in and out, and you are making your body more efficient at getting oxygen from the air, from your lungs, through the rest of your body, through your veins. But anaerobic is when basically you just use everything that you possibly have, and you kind of do this weird reverse kind of almost fermentation kind of thing.
Whoa.
Where you create a different amount of energy from glucose, and then from there, it's not quite as efficient, but you can do it in short bursts. But then you have to replenish all the oxygen in this area and get rid of these acids that you created, which is like lactic acid in your muscles when you feel really sore and tired.
Yeah.
That is this same kind of response.
How can it be respiration if there's no breathing?
Well, you're still respiring using oxygen and glucose and other things, but you're also using different other parts.
Wow.
It's actually extremely complicated. I don't know that I am the best to explain it.
Let me take this one, Case.
Yeah, Alice, please.
It sounds like a backup generator or something.
It kind of is, yeah. And it's like a backup generator that you use for like really quick bursts, and then you refill that fuel some other way.
Wild.
Yes. So this tree does exactly that.
Okay.
Not only that, but it oxidizes its rhizosphere, which means it takes...
You are oxidizing my rhizosphere right now.
All right, I'm sorry. I'm going to take a step back, okay?
Whoa.
Things are getting pretty out of hand over here.
What the fuck does that mean?
Well, it means that they take oxygen from up in their stem. They absorb it through lenticels in the bark,
Okay.
in their twigs, in their stems, and they move it down into the roots. So then the roots start to let oxygen out into the area just around where they are.
Okay. Like a little atmosphere.
Yes, they create the tiniest little atmosphere around it. There's a little bubble of oxygen that starts to flow from the roots into the area around them.
That's fucking weird.
Isn't that wild?
So it's kind of reverse, because usually the tree gets oxygen through the roots, right?
Yes.
But this is getting oxygen through the leaves and sending it down to the roots.
Yes. No, I'm sorry. Not the leaves.
No, lenticels in the upper branches.
Yes, exactly.
Wild.
And here's the other fun part about this is that it makes alcohol.
Let's cut this thing open, have a party.
Let's do it. Seriously, it is throwing booze into the water along with oxygen.
The chemical alcohol.
Yes, ethanol.
We're not talking like smearing off ice.
No, it's all the same thing. Ethanol. Ethanol is the booze that gets you drunk.
Ethanol is alcohol? Mm-hmm. Whoa. Okay.
That's right. So this is alcohol fermentation.
That's
fucking literally
crazy.
What they do. So that is a part of their anaerobic work. So our swamp Tupelo will actually initiate these new roots that will accelerate this ethanol production. So they accelerate their anaerobic respiration.
Yeah.
This process being slightly different actually creates alcohol, which is the alcohol you drink, ethanol.
Yeah.
Then it shoves that and it goes out into the world and it uses that to basically allow itself to create a little bit more energy, use the energy from this like weird backwards way of getting oxygen from the upper side down into the roots, then used in this weird thing. And it does this and acclimates itself to living underwater for like the entire growing season.
That's fucking weird.
It's so weird.
It has like transformed itself into an aquatic creature.
Yes. Yeah. It's transformed itself and it uses the alcohol potentially as a new kind of small energy source. So it's like, okay, if I'm going to be doing all this, I'm going to take this and I'm going to turn that into a little bit of booze. I'm going to drink that booze and I'm going to get a little bit more energy off of my booze. And then I'm also going to be getting ready and like live in these like hypoxic conditions, which means like essentially they don't have any oxygen in these crazy swamps they live in.
Wow. I wonder if now I'm like, do humans do that when we what is it called? Anaerobic respirate, and that's what like a runner's high is.
Oh, honestly,
are we like getting a little bit drunk?
That's a great question.
It could be.
It could be. Honestly, I don't know enough. We need to talk to someone out there who knows the exact right answer to this.
Yeah.
I don't think so because I think we produce more like lactic acid from this. And so it's just a little bit different than kind of your ethanol alcohol, but
endorphins and things.
I don't know, honestly.
Yeah, it's interesting. Wow. Yeah. That is bizarre. I get it is sort of like the other side of the spectrum of like a tree that grows in the desert, you know?
Yeah,
it's
right.
Like, how the fuck did you end up here?
Yeah. And like it's like so strangely and uniquely complicated, but also like they did these studies that I'm referencing back in like the early 70s and the 60s. So they're like, yeah, we've been doing this. We know exactly how this works, and we didn't need a big intense computer system to kind of sort this out.
Sure.
But they essentially create these trees, like different kinds of roots that do a different kind of thing. So it's not just your normal root. They're like, oh, now we're underwater? Okay, root B, you're on. That root comes out and changes all these like tiny little things, and they grow ever so slightly differently with different amount of suberin, which is kind of the corkiness inside of the cork of bark. So they like have these little tiny anatomical differences and then these little tiny chemical differences, and they affect their environment just so, and they can also live without having any problems with, 30% CO2 or something like that.
Crazy.
So they're just like, okay with doing all this. And a bunch of other swamp kind of plants will also have the same kind of thing.
Yeah.
So this is very much the three adaptations that you need to live in this environment. Other plants that live in semi-ish kind of like environments like this, rice is one that a lot of people have studied. Rice doesn't have all these same adaptations. So rice doesn't like to be inundated quite as much in the same way.
What about cranberries?
Cranberries, we only actually flood cranberry bogs in order to harvest.
Okay.
And because frogs love to eat all them spiders. Lovely frog in a bog.
We know all about that. So I guess my final question here is, if you take a swamp tupelo and you plant it very specifically in like rich, temperate soil, will it create the same? I mean, is it in the species DNA? Is it gonna create the same kind of roots as the one that's growing in the black tea?
No. Because it only creates those roots as a response to the flooding.
Okay, so it'll create just normal tree roots.
As far as I know, it'll grow just pretty normally. Yeah,
and it won't obviously create a butt.
Oh,
butt.
I don't know if it'll create its swollen bottle butt base.
Look at that swollen bottle butt base.
Swollen bottle butt base. That's what I'm talking about.
Well, Casey, it's time to give a review and a rating to this swamp tupelo. We got to do that after a quick break. We'll be right back with Completely Arbortrary. Welcome back to Completely Arbortrary. That was our discussion of the swamp tupelo. It's time to give it a rating, and here's how it works. We're going to give some final thoughts on this creature from the Black Tea Lagoon, and then give it a rating of 0 to 10 golden cones of honor. Casey, as our resident expert and author, we'll begin with you.
Wow, thank you.
You really did it.
So first off, I need to shout out Sam Hamilton, which is she's a research technician at the College of Agriculture and Forestry Life Sciences at Clemson University.
Great.
Initially turned me on to looking at this. So hopefully, Sam, thank you for this idea. Send me some information, but please don't get too upset with how horribly I absolutely described half the things that we talked about today. Being a research technician, I'm sure she was like, oh my God, what an idiot. I think that the swamp tupelo, it's one of my favorite things. I actually didn't know that there was a difference between the swamp and the water tupelo. I didn't know there were two different species. There demonstrably are. Anyone who thinks otherwise, you're wrong.
Okay.
And I think one of my favorite things when I visited these swamps was just looking around and seeing these wildly developed buttress bases. I love a buttress base. Don't get me wrong. I like a good trunk.
Sure.
But give me that buttress base. That's what I'm about.
He cannot lie.
I just think they look so cool.
They're very cool.
I did not get to see them when they had their full leaves on, which I really would like to see. But I think in order to see them in full leaf, you have to deal with a wild amount of mosquitoes in these areas.
Not happening.
There's actually, in Congaree, they have a mosquito meter, and it's just how bad are the mosquitoes today?
Oh my God.
Yeah, it's really funny.
Like a fire danger meter?
Exactly, yeah.
That's fucking awful.
Yeah, it's really funny. They are a tree that I need to see in their full glory.
Okay.
But having said that, I just think tupelos are really just they're lovely trees. We have the black tupelo. It's planted out here all the time. I'm like, yeah, that's a nice tree, but it's a nice tree that I still I'm happy to see every single time I see it. I love this response, like you said, a tree that has like the desert trees. How did you do that? How did you develop this amazing strategy to survive in this place that seems so inhospitable? So all that to say, I think I'm going to give it a straight 8.0.
Nice.
Right there along the board. It's a little bit above 3/4 average.
That's great.
I think it's a great tree.
A wonderful score for the swamp tupelo.
I would go hang out next to it and slap its butt.
Hey, easy there.
Tris base. Excuse me. Sorry. You cut me off. Okay. You cut me off.
Well, Casey, here's what I think about Nyssa biflora. I like it a lot.
Okay.
Not impressed by any one thing except for this water adaptation. I think that's very cool.
Yeah.
And I always appreciate a tree. I think in the past we've called it why do you grow their-ness?
Yes. Yeah.
And this has some serious why do you grow their-ness.
Yeah,
because
absolutely.
it doesn't really seem like the tree is getting much out of it. It's just like a survivor, It's not maybe it's not thriving, but it's definitely surviving.
Yeah, I have seen them thrive. They can get over 30 meters tall.
Are they happy though?
That's a great question. I don't know.
Wouldn't they prefer to be somewhere else?
That's a great question, Alex. That is an internal debate, I think, with plants, right?
Sure.
Where you see them growing, like conifers is the best example. You see them always growing in the most extreme places. In fact, this one grows with the bald cypress very often.
Yeah.
So it makes you wonder, like, did you choose that, or are you relegated to this location, and you're making the best with what you got?
I think it's just playing the cards it was dealt.
Yeah.
And it has done so really well. It got to the final round of the poker tournament. It didn't win, but it did pretty good.
It seems like it's doing pretty good. I don't know. It hasn't lost yet, maybe. I feel like when you lose, you're extinct. And this tree's like,
yes.
I ain't dead yet.
Yeah, no. Maybe I'm in the loser's bracket, but hey, that's still in the tournament. So I'm going to give this guy a 7.5. I feel really good about it. It's a strong 7.5. It's bolded.
Yeah, I really like the idea of having a strong versus a weak 7.5.
There is something to it, don't you think?
Exactly. One day we're like, well, this tree's great, so like I'm gonna give it a weak 7.5 because I'm just not impressed.
Yeah, like it's falling towards 7.4.
Yeah, it's not growing up beyond 7.5.
But this is a strong 7.5 with potential for an 8, as we've seen clearly today.
It can get there.
All right, Casey, that was our review of the Swamp Tupelo. We hope you enjoyed it, everyone. It's time for a game. And we have one that is a house favorite, at least.
Oh.
This is the slang game. Slang! It's the language of the people. Slang! Make sure you know what it means. Slang! Before saying it out loud. Slang, 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 slang. All right, Casey.
Slang.
Casey, here's how the slang game works. I'm going to give you a few pieces of slang from some culture or place or whatever language. And we are going to kind of daydream about what that slang word would mean if it were applied to the tree world.
Love this.
And that could be anything involving trees. So today is the slang game Clockwork Orange edition.
How did we get to Clockwork Orange?
Have you seen this movie or read this book?
I have. I have seen the movie. I have not read this book.
In that book, especially in the book and the movie, the people in this place, they talk very strangely.
They really do. Like, it's famous for having that like really strange kind of afflection.
Yes.
Affectation.
Well, they have just like slang for everything. It's a dialect called something. It's like a mixture of English and Russian, basically.
Yeah, okay, gotcha.
It's kind of an alternate universe where we lost the Cold War and now like Russian influence is pervasive in English-speaking countries.
That's such a funny way to go about it.
Yeah, it's a great book. It's hard to read, but
yeah, well, I'm sure, because who knows what they're saying.
Sure, and the rape.
Yes. Well, yeah.
So, Casey, I've got 5 slang terms here from Clockwork Orange.
How did you think of Clockwork Orange to be the choice?
I don't know how to answer that.
Okay, I was thinking you were going to be like, we're going to go down and find a bunch of bayou swamp slang.
That would have been so good.
I'm okay with this too. I was like,
it's not too late.
No, certainly not, but you already did the research on one.
God damn it. That would have been so much better. Oh, well, we have this instead. All right, Casey, your first word is yarbles.
Yarbles. All right, well, I think I have an idea.
Hit me.
I think a yarble is like hanging fruit off of a tree. So kind of like our little Nyssa, it's got these 2 little droops that come down. I feel like, oh man, that tree is just covered in yarbles. I'm still going to give an accent.
Sure.
So I'm going to imagine that this is still translating a Clockwork Orange into the bayou.
Yes, it's Cockney. What is that dialect called? Louisiana French
Creole. Yeah.
It's Cockney Creole.
Yes, Cockney Creole with a little bit of Russian in it.
Yeah.
Okay, so I think it's just like it's a bunch of berry-like fruit hanging from a tree, a yarbles, or a bunch of yarbles.
Casey, you fucking nailed it.
What?
Yarbles means balls.
Seriously?
Yes.
Yes.
It means testicles.
All right. Then we have already determined it's essentially the same thing on these plants. Okay. So
and cool. It comes from in the book. It comes from the Russian word for apple, which is yablako, or from the Russian word for eggs.
Wow.
So pair of balls.
Nice.
Yarbles.
Okay. This sounds great.
Or possibly from the Cockney of balls.
Yeah.
Like your balls.
Yibbles.
Yarbles.
Wow.
You know.
Man, language, baby.
Pretty cool.
Get
All right.
out of here.
The next slang, Casey, is toll chalk.
Toll chalk. Toll chalk.
Toll chalk.
Ooh.
I think it's like a cutting technique.
Yeah, I was feeling like it's what you describe. It's the action of cutting into a tree with an axe.
Yeah.
You know?
Yeah, sure.
Like I was toll chucking the other day, and
Totally.
the axe handle broke. Would you believe it?
Chalk is like chuck, which is like to cut wood.
Yeah,
right?
like a woodchuck.
Yeah.
They famously chuck wood. And no
If
one
they
knows exactly
could.
how much.
And how much would it be? Yeah, I mean that's a great one for toll chalk.
Okay.
A toll chalk is like a smack, like punching something or hitting somebody on the head.
Okay, so kind of we're sitting here.
Give them a little toll chalk.
We're sitting here good with that. Okay.
Yeah.
We're spot on.
And it comes just from the Russian word for to hit something.
Toll chuck.
Okay, the next word, Casey, is orange.
Okay. That's already a term. It's a Hesperium.
Okay. Any other guesses?
Anything else, buddy? Okay. So this is...
Yeah, think outside the box. An orange.
Yeah, think outside the box. An orange.
I've got one.
Okay, what do you got?
You know how people describe things as a lemon? Like if it just doesn't work
Yeah,
very
it's
well?
just not very good. Yeah.
I think an orange is like that, but it's different somehow. It's like maybe applied to trees, like the runt of the litter. That,
I see.
That's the orange over there that just like refuses to grow.
Yeah,
you know?
that's the tree we're thinning out of the stand.
Yeah.
I kind of feel like it's just it would be a generic term again for a fruit. Like, oh, now that's just the orange. So it's like doesn't matter.
Oh, sure.
It's like a grain, you know. It's just a generic term for something.
Yeah.
But that feels a little too straight on the nose. It's not slangy enough.
Sure.
It's like, okay, is it to orange? Is it a verb? Or is it a noun, which is unorange? An orange. Orange.
I think it could also be like a brand of chainsaws.
Oh.
And then when you just like
get my
tissue,
orange.
where you just like grab, even if it's not an orange brand,
Yeah.
just go grab my orange. my
Yeah, okay,
chainsaw.
so it's like the Kleenex, the crescent wrench.
Yes.
Yeah, I gotcha.
Yeah.
You have two great ideas. I'm still stuck on this.
You can borrow one of mine.
Yeah, okay, I want to go with the chainsaw. That works
Okay,
for me.
Great.
Okay,
It's a person.
a person is just an orange?
Yeah. It's a man. And it comes from the Malay word orang.
Oh.
As in orangutan.
Yeah.
Orangutan, which is the forest man.
The forest man.
Yeah.
That is so cool.
Orangutan means man of the forest. Casey, next word is Sammy.
Sammy?
Sammy.
Okay.
It's alive.
It is. Honestly, yeah. This to me, I feel like it should be like an electric eel or something. Like some kind of swimmy and sleek, slimy creature in the swamps.
Is that tree related? It just lives among trees.
Oh yeah. Okay. Good point. Okay.
I was going to give it to you,
but I broke the rules.
it sounded like you didn't know what you were saying.
Yeah, I was just straight responding. I knew what I was saying, but I forgot the actual context of what we're saying.
Yeah.
I was just thinking swamp at this point.
Sure, yeah. I should have done swamp words. I'm sorry.
No, you're okay. This is a Sammy.
Sammy.
Honestly, I kind of feel like a Sammy relating to a tree is like it's like a forest grown tree or a tree that's like it can't support itself. It was grown in the forest. It's really noodly is what the term is we use every now and then. Where it's just like
funny.
a tree that like if you lose all of its buddies, it just kind of like falls over. So they're like trees that look like they kind of arc over to the ground or like go from straight up and then just bend over for no good reason. Yeah, it's like, oh, there's another Sammy tree. It's just like a loosey-goosey kind of tree that is growing on the edge. It kind of flops over. It's not one of those trees that grows straight up, solid, that can just like support itself. It's a tree that kind of got it.
It's kind of what I used for orange. Like a tree who's just like the runt on the edge.
Exactly.
Can't really
yeah.
grow.
Nah, there's a Sammy over there. Just cut it out. Use
I love
it
it.
for firewood.
That's great.
That's what I think.
I think a Sammy might be like a kind of geological feature within a forested space.
Ooh.
So like a steep drop off. There's
I
50
see.
yards that way is a Sammy that leads into this part of the forest.
So be careful, climb down, but it's going to be really cool.
Yeah.
Okay, I like that. I like that a lot.
Sammy in Clockwork Orange means generous.
Generous.
As in good Samaritan.
Oh, wow. See, that definitely reminds me of Cockney in that regard.
Yeah, totally.
Nice.
He's a good old Sammy.
Yeah.
He's quite Sammy.
Interesting. Oh, God, man. Slang.
You okay?
I am. I just love slang. Thanks, Alex.
I just
Thank you.
love slang. Feed it to me. Last word, Casey, is staja.
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 Staja. Staja. Man, honestly, this to me feels like a vibe. Where like you walk up and you see a tree that just has a certain staja about it.
Oh,
you know?
cool, yeah.
Like, whoa, look at that. Like you can't quite put your finger on it. Is it the color? Is it the ephemeralness? What is it? What is it? How it's growing? It's like it's got a lot of staja to it. That's just like, I love that.
It's like that. Is it a Norwegian term, or at least from that area, kuselig, which is like a cozy vibe.
Ooh, yes.
Like you walk into somebody's apartment and they, oh man, this has got a perfect cozy vibe.
Yeah, which is kusaleg.
Yeah, kusaleg.
This is some really good kusaleg.
Yeah.
Yes, that's exactly where it's at. Like there's just the staja, man. Look at that. Ooh.
Sweet. I love that. So staja actually comes from the beginning of the words state jail.
Really?
It's like a detention center.
Exactly. Okay, so like a correction center or a penitentiary of some kind.
Yeah. Staja.
Right. Yeah, staja. Man, okay, I love that. But I think I'm going to start. I'm going to use this and see if I can popularize it. You know, Justin Davies.
Yeah,
he's got a term that I think he came up with at some point, and he didn't know what to say. So he's just like, this has a lot of chatoyancy. Yeah. Now, and anytime he gets like a really beautiful piece of wood, and it just looks like it shines in this perfect way that you can't really describe.
Yeah,
it's got a lot of chatoyancy.
I love that.
Yeah, and I don't think he can physically say it without adding like a whole like slow down and like echo every single time. So I want to make this staja. Like, what is it about this tree? It's staja.
It's just a staja to
I'm going to take this and turn it into a different slang term.
Yeah, I love it.
Staja.
That's how language evolves, Case.
Exactly. So let's evolve some language starting right here.
Well, Casey, that was the slang game.
Wow, man. Honestly, house favorite. You're totally right. I love this game.
It's so fun.
It's so good.
It's a great game, and I did a great job coming up with it.
Absolutely.
Casey, it's time for our Completely Arbitrary AMA. If you want to support the podcast and ask us questions, become a Tremia member at arbitrarypod.supercast.com. And this week we got one from Patrick.
Hi, Patrick.
And the subject line is galls. Patrick says, can you explain what a gall is from the tree's perspective?
This is great. It's a good question.
Like, is the response of forming a gall codit, C-O-D-I-T, I don't know what that means, or some enzyme reaction or something? I describe them as tiny nurseries for baby wasps, but I'd like to understand what is actually happening in the tree. Thanks, Patrick.
This is great. That's a wonderful question.
What the fuck is a gall? Please also define codit as an acronym.
I will. So codit means the compartmentalization of used to be decay, now it's damage in trees.
Okay.
Codit. So codit is a wound or a damage response of a tree where if you cut off a branch or you nick the bark or something like that, then you create a little piece of dead necrosis tissue. So the bark dies and now you have this exposed wood area.
Okay.
Compartmentalization in trees, codit, is the response of the tree to close off and compartmentalize that space away from the rest of the living or dead parts of the tree.
Okay, it's like a quarantine zone.
Exactly, yeah. And we've talked about it in two different ways. There's 4 different walls, and this is extremely generalized. The first one, the tree physiologically cuts off and puts up barriers, chemical and physical barriers in the cells that first stop the decay from going in towards the middle of the tree. And the
Specifically,
Yes.
interesting.
The second one is up and down, so it stops and puts the this kind of ring of physiological wall that keeps it from going up the stem. So now you have going in towards the center of the tree, then you have it going up the tree in the upwards or downwards towards the roots or towards the branches way.
So it's stopping it from basically like spreading to vital areas.
Exactly,
Okay.
yes. And then the third one is going around the tree. And the fourth one is putting a new wall of nice wood over the top of it.
Okay.
And that is just it regrowing its new callus wood over the top of the wound.
That's just incredible.
Yeah, it really is. And so those are the 4 main walls of codit. And like you said, the way I imagine it is the Titanic is driving and it hits this iceberg. Sorry, floating,
I guess,
moving,
what
whatever
does
it's
a boat
doing.
do? I guess it drives.
Yeah, it's going, it's sailing. It hits the iceberg, and then famously in the movies, they like were closing these blast doors kind of things, trying to just compartmentalize off the space that was flooding.
So full of poor people.
Exactly. Yes, all the people in the engine room. Yeah, they definitely did not make it. So all of as those doors are shutting, those people are running and getting out, but then as they shut, the water then stays right there. It doesn't move through the rest of the ship.
Yeah.
The idea being that they essentially compartmentalize off the wounded area, and in this metaphor, water is decay but moves way slower.
Okay.
And it would go through and break down all these things. So over time, that's how trees keep themselves alive and keep one wound from killing the whole tree. Some are better at it than others. It is not, though, what is happening with galls.
Okay.
All right, now we're on track again.
That was the first kind of part of this question.
Yeah, when we talk about ancient history and we talk about the Titanic, and now we're talking about trees again.
It's okay. I've truncated it to about 30 seconds.
No! So a gall is a response from the tree, but it's not a wound response. It's actually more of this enzymatic response from an insect. So the insect puts a little teeny tiny hole and puts in a little egg.
A wasp specifically?
Yes, but there are also other insects that do this.
Like a fly gall or
there's
mosquito
some
gall.
Like mites will do this.
Okay, just for the example, let's use wasps.
Yes, absolutely. It's perfect because they are very much the quintessential.
Okay.
So what they do is they put a little bit of enzyme in the leaf tissue. Most of the time it's leaf, sometimes it's buds, sometimes it's cones. It can be almost any part, but one of the more fresh parts. So it's not going to be like in the old wood most of the time, at least not from an insect. So they pop in their little teeny tiny egg and they put all these enzymes around it. Those enzymes create the conditions where the plant essentially says, oh, I have to grow. And it grows new cells and they divide and they create this new little chamber of plant cells that are induced to grow around the individual egg and then becomes a grub as it hatches. And that grub usually eats a little bit of that tissue, or it puts its mouth parts in and sucks juices from the tree itself, from the leaf or whatever.
This is the insect's enzymes communicating with the larva.
No.
The baby.
The
with
insect,
the tree.
With the tree, exactly.
The enzymes can talk cross species?
It's not that they can talk. It's that we humans can do this with a lot of different things, but you put a certain chemical on a certain part and it will induce the tree to do something.
Oh, sure. Okay.
So what we usually do would be like a plant hormone that would make roots come out. So you dip a little root hormone on a certain part of a plant, then keep it moist, add some soil, then that induces the plant to grow a bunch of roots out from a twig, an otherwise not root-producing section.
So it's just a universal chemical reaction.
Yeah, exactly. But in this case, it is not quite so universal because the insect puts in just the right kind of mixture of magic chemicals and hormones and things that it produces that then create the conditions in that little section of tissue in the plant to create a certain little bit around its little egg.
Wow.
So it grows in a different way. So you'll never see like, oh, that's just a normal looking piece of plant. Oh, whoa, there's a gall in there. The gall is always very different looking than the rest of the plant.
Interesting.
Often on oak trees, for example, it looks like a weird, like, I don't know, if it's on an acorn, instead of an acorn growing out and looking like an acorn, it looks like almost this exploding flower kind of thing that looks really swollen and unhealthy.
Yeah.
If you look at it closely and you imagine what it looks like, you're like, ugh. That's like the most deformed, ugly acorn I've ever seen.
It's pretty gross.
Yeah. Here in Oregon, we have the Oregon white oak, and there's a gall that's produced by an insect that looks like a perfectly spherical ball that's attached to the bottom of leaves.
Yeah.
And that is really cool. I used to love finding those because you can rip them open, and you can find this teeny tiny little bug on the inside, this little grub way in the middle.
Aw.
So they are, there's thousands of different varieties. Lindens have mites that create these little like vertical lines that look like these little, I don't know, little warts that pop up. And they look like warts that popped up that are actively trying to escape. Like, if you see a cartoon and they like shoot into something and then they like go boom all the way through. It looks like that paused and in motion,
Like a big erection.
Yeah, exactly.
In a pair of
Like
pants.
a dozen of them on, on this little leaf. So, so it's not a coded response. The tree is not having a stress response saying, bah, something's gone wrong. They essentially get tricked to grow a certain kind of tissue in a certain place, and the little chemical cocktail that the insect puts in there creates the exact perfect conditions that the grubs need in order to survive and be protected. So they get a little bit of food. They will not die because all the other plants in the world or all the other animals would be like, well, nothing's there. I'm just going to move on. So they get this nice little protection from the plant itself.
You know what's funny, Casey? I think this whole time until just about 5 seconds ago, every time we say gall and talk about galls, I've been thinking burl, which is something entirely different, in fact.
Yes, that is entirely different.
I was like, this doesn't seem right.
No way.
Yeah.
And so you just looked it up. Is that kind of the thing that really tipped you over the edge?
Well, yeah. I mean, sort of. But we were talking about like how a wasp will lay in. It's like, that sounds very tiny.
Yeah.
And I'm thinking, aren't burls like big, bulbous things?
Yeah, they certainly can be.
So yeah, I learned something today that a gall and a burl, two different things.
Two different things.
Boy, girl, burl, gall.
Burl gall.
That's a good vocal warm-up.
Yes, yeah, let's try doing that.
Boy, girl, burl, gall.
Done. Let's record a whole podcast. We're ready.
Wait, we just did.
Oh, dude, we got to do another.
Thank you so much,
Wow, what a fun question.
Patrick, for your question. Your gall. The gall.
The gall to ask such a question.
And if you have a question for us, like I said, become a Treemium member, arbitrarypod.supercast.com. All the cool kids are doing it. Become a tree hugger, or you could become a cone clubber and go clubbing with Casey and I.
Yep.
And you also get monthly stickers, botanical stickers of different flowers and cones and acorns and leaves and such.
That's right. Also, remember, we got a big sale going on. Hashtag blowout.
That's right.
Come get it done.
That's right. Arbitrarypod.com/merch. Literally everything is on 30% off with the coupon code BLOWOUT.
Mm-hmm.
Casey Clapp.
Alex Crowson, we did it.
Thanks for, I think, Creature from the Black Tea Lagoon is the final one.
Yeah, if only we could have made this Tupelo, then it could have been the Creature of the Black Tupelo. But we're not talking about the Black Tupelo.
No, we're not. And I learned the distinction today.
Mm-hmm. Yeah, a lot of people don't know this.
All right, go buy Casey's book. It's been out for a week. What have you been doing? And
tag me on Instagram. I'll tag you back.
There you go. Mm-hmm. That's like interacting with a famous person.
Yeah, that's exactly what it is.
Thank you so much for listening to Completely Arbitrary, everybody. We'll see you next time. Bye.
See ya. Completely Arbitrary is hosted by Casey Clapp and Alex Crowson.
Our music is by AIDS and the Mini Vandals, and our artwork is by Jillian Barthold.
To support the podcast and get rewards in return, become a Treemium member at arbitrarypod.supercast.com.
Thanks for listening.